Welcome back to Science Corner, everybody. We always love to unpack some really cool science stuff here. Today, we are diving deep, as always, into something that seems very simple on the surface, skipping stones, but I think we're going to find that it's more complicated than it looks.
Definitely, yeah. More than meets the eye.
So we've got some great source material on this. We've got a couple of articles from Scientific American, a really cool piece from Wired magazine. And our mission is to really figure out the physics behind how these stones manage to bounce across the water. Like what actually makes for a good skip. So for those of you out there who have actually tried this, have you ever stopped to think, like, how does that actually work?
Right.
Like what makes the stone skip instead of just, plummeting straight down into the water?
Exactly. It's one of those things you kind of take for granted as a kid. You're like, oh, I can do this.
Yeah.
And you get older and you're like, wait a minute.
How does it work?
How does that happen?
Yeah. So let's break this down. Okay. The sources point to a few key factors. First up, the angle.
Yeah.
Apparently, there's like a sweet spot around 20 degrees
Right.
for getting the best skip. But what's so special about that angle?
So think about it this way. If you throw a stone straight down, it just sinks, right?
Yeah.
Too steep of an angle, it's just going to kind of like belly flop.
Right.
But if you throw it at too shallow of an angle, it'll just kind of hit the water and stop.
It's like plop in, yeah.
Exactly. So that 20-degree angle is kind of a sweet spot. It lets the stone interact with the surface of the water in a way that maximizes the lift force
Okay.
while also minimizing the drag. So it's kind of like finding that perfect balance between the stone wanting to stay up and the water wanting to pull it down.
So like similar to a paper airplane.
Yes.
Yeah.
Exactly like a paper airplane.
If you don't get that angle right, it just nosedives right into the ground.
Exactly. Too steep and it goes straight down. Too shallow and it just kind of flutters and falls.
Right. Okay. So we've got the angle. What about spin?
Spin is absolutely crucial. You need a lot of spin, like around 10 revolutions per second for a good skip.
10 revolutions per second.
Yeah, that's really fast.
It's crazy fast.
It is. But that spin is what gives the stone stability. It's like a gyroscope.
Ah, okay. So it's that same principle that keeps the spinning top upright.
Exactly. The spinning motion creates this force that resists any attempt to tilt the stone. So as it's skipping across the water, that spin keeps it level and prevents it from tumbling, which would cause it to sink.
So it's like the spin creates an invisible force field around the stone, keeping it stable.
Yeah, you could think of it that way.
Okay, makes sense. And of course, we've got speed, right? Everyone knows you need to throw it hard. But how does speed actually affect the skipping?
Well, the faster you throw the stone, the more energy it has.
Right.
And that energy is what allows it to overcome gravity and the resistance of the water. The more energy it has, the more times it can bounce off the surface before it finally sinks.
So more speed equals more skips, basically.
Exactly. You need a minimum speed of about 2.5 meters per second just to get that first skip. But if you want to get those really impressive multiple skips,
Right.
you need a lot more speed behind your throw.
Okay. So we've got angle, spin, speed. And I have to admit something. I always thought surface tension was like the main reason why stones skip.
I hear that a lot. It's a common misconception. Surface tension does play a tiny role, but the real star of the show is hydrodynamic lift.
Okay. Hydrodynamic lift. What is that?
So imagine this. The stone hits the water at that perfect 20-degree angle, right?
Right.
And it's spinning like crazy. This forces the water downwards.
Okay.
And because every action has an equal and opposite reaction, the water pushes back up on the stone.
Ah, okay. Newton's third law.
That's right. And that upward push from the water is what we call hydrodynamic lift. It's the same principle that makes airplane wings work.
So the stone is basically surfing on a wave of its own making.
Exactly. And this French physicist named Frédéric Bouquet, he actually did a bunch of research on this. He even built a model to simulate skipping stones. Wow.
And he figured out that to get those crazy record-breaking skips, like the guy who skipped a stone 88 times.
88 times. That's insane.
Yeah, that's the world record. But Bouquet found that the key is minimizing the energy loss with each bounce.
Okay.
The stone needs to maintain its speed and spin to keep skipping. It's amazing how much physics is involved in something that seems so simple.
That is mind-blowing. And speaking of mind-blowing, the applications of this stuff go way beyond skipping stones at the lake, right?
Absolutely. This stuff is used everywhere, like naval engineering, for instance.
Really?
Yeah. Shipbuilders, they use these principles to design boat hulls, especially for ships that need to go fast.
So like speedboats, things like that.
Exactly. By shaping the hull to mimic that perfect skipping stone angle, they can reduce drag and increase lift, which makes the boat much more efficient.
So it's like those birds are basically skipping across the water.
In a way, yeah. And then you've got hydrofoils, those boats that actually lift up out of the water.
Oh yeah, those things are wild. They look like they're flying. They do, and that's basically what they're doing. They're using hydrodynamic lift to rise up out of the water, which reduces drag even more. It's like skipping on a whole other level.
Wow. So we've got boats that skip. What else?
Believe it or not, this stuff was even used in World War II.
No way.
They had these things called bouncing bombs.
Bouncing bombs.
Yeah, I know it sounds crazy, right? But a British engineer named Barnes Wallis, he designed these bombs that could skip across the water, just like a skipping stone. They would spin for stability, and they were launched at a precise angle so they could bounce over torpedo nets and hit targets that were really hard to get to, like dams.
That is so cool.
Yeah, it was pretty ingenious. They even made a movie about it, The Dam Busters.
I'll have to check that out. But bouncing bombs, that's incredible.
What else about space travel?
Space travel. You're kidding, right?
Nope. Turns out the same principles that make a stone skip across the water can also be used to control a spacecraft as it re-enters the Earth's atmosphere.
You're blowing my mind right now.
When a spacecraft comes back from space, it's traveling incredibly fast.
Right.
And if it just slams into the atmosphere, it'll burn up.
That makes sense.
So they use this technique called a skip re-entry. They basically bounce the spacecraft off the atmosphere.
Bounce it? Seriously?
Yeah. By controlling the angle and speed of the spacecraft, they can use the atmosphere to slow it down gradually, preventing it from burning up.
So it's like a super high-tech, super high-stakes version of skipping stones.
Pretty much.
Yeah.
And it's been used on everything from the Apollo missions to modern-day capsules.
Wow. From skipping stones to space travel. Who knew?
And there's one more application I wanted to mention. Super cavitation.
Super cavitation. What's that?
It's a way to make torpedoes go really, really fast underwater.
Okay. How fast are we talking?
Like hundreds of miles per hour.
Whoa. But how is that even possible? Doesn't water create a lot of drag?
It does. But with supercavitation, they basically create a bubble of air around the torpedo.
A bubble of air. How do they do that?
It's pretty complicated, but they basically use the torpedo's shape and speed to create a low pressure zone around it. And that low pressure causes the water to vaporize, forming a bubble of air.
So the torpedo is basically flying through the water inside a bubble.
Exactly. It's like skipping a stone beneath the surface.
That is so wild. I never would have thought that something as simple as skipping stones could have so many amazing applications.
It just goes to show that science is everywhere. You just have to look for it.
Absolutely. Well, folks, I hope you enjoyed this deep dive into the surprisingly complex world of skipping stones. Next time you're at the lake, take a closer look at those skipping stones. You might be surprised by what you see, or at least think about all the amazing science behind it. Until next time, keep exploring the world around you. We'll catch you on the next deep dive.